Hello students, welcome to this energy lab. Today we are going to discuss about the experiment number 7, that is single cylinder 4-stroke petrol engine test rig. Okay, so let us discuss in brief about this experiment. Okay, the aim of this experiment to conduct the performance test on 4-stroke air-cooled petrol engine. Here this setup is based on the air-cooled engine. Okay, and the description of this experiment, that test rig consists of 4-stroke petrol engine to be tested for performance is connected and to the alternate couple to the electrical coils to apply the load on engine. Okay, so these are the engine specifications which are supplied by the designer, and the type just we gone through this. This is the 4-stroke petrol engine which is having air-cooled engine, and it is made by the Graves, and the power output is 3 HP, that is 3 horsepower and 3000 RPM, and the bore diameter is given, that is 70 mm, and the stroke length is 66.7 mm, and the compression ratio for that petrol engine is 16.5:1, and the cylinder capacity, that volume of that cylinder is 553.0 cc, and starting of this engine is by hand cranking, and the diameter of the orifice is 12 mm. Okay, so these are the specifications which are helpful for the calculating the various values, and this the specific consumptions we can calculate it by taking, as we discussed in the previous experiment, there is a total fuel consumption and it's a brake power. Okay, so the heat input we can calculate it by using total fuel consumption, and it's a specific there is a calorific value of that fuel, that is petrol. Calorific value is already we know that is 48,000 kilojoules per kg. That is an approximate value. Okay, and we can calculate the heat input, that is in kilowatts. And next, air fuel ratio. That air fuel ratio is the ratio of that mass of the air to the mass of the fuel in kg per minute we have to consider, and once if we get this value in kg per minute, later we can convert into kg per second, and the mass of the air is equation is 60 into CD into A VA into rho A, and we don't know the VA values here. Okay, VA is the volume of the orifice air, and the equation is under square root of 2G HM divided by 1000 into rho W by rho A minus 1. That is 133.47 under square root of HM. This is the air fuel ratio, and CD value is 0.62, that is A is equal to 5D square by 4, that is in meter square, that the orifice diameter is 0.014 meter, and the G is 9.81 meter per second square, and rho A is density of the air, and it is 1.10 kg per meter cube, and rho W is water, that is density of the water is 1000 kg per meter cube. So these are some very important specifications which are helpful for knowing these values and substituting the formula and get the answer. And to calculate the indicated power, we have an equation: indicated power is equal to brake power plus frictional power. So we know that brake power, but we don't know the frictional power. So how we can calculate this frictional power? The frictional power is a 1/3 of this BP, the maximum 1/3 of BP power, that will be considered as a FP, that is the frictional power. That is also based on the Williams concept, Williams line method, and these values will be getting from this maximum brake power, and we will get 1/3 of brake power, we will get the FP. The FP and BP if we add it, we will get the indicated power, and that is in terms of kilowatts. Once if we know this IP, we can calculate mechanical efficiency, that is BP by IP, that is brake power to its indicated power, we will get mechanical efficiency. Once all these parameters we found, then we can plot the graph on various parameters, that is the TFC versus BP, and brake thermal efficiency versus BP, and mechanical efficiency versus BP, and fourth one is SFC versus BP. These are the method to plot the graph for different parameters. So okay, so let us will discuss by conducting the experiment of how to take these readings. Thank you. Before that, the tableau com also is there. Just glance it. What are the content in the tabular column, the load in kilowatts and engine speed in RPM, and voltmeter reading and ammeter reading in volts and as well as amps, and the fuel burette readings. So we can see that the volume as well as time in millimeter and seconds respectively, and the various temperature points, that is air inlet and exhaust outlet, and the water inlet and water outlet temperature, and also the exhaust outlet temperature of the calorimeter, and airflow meter and the energy meter are there, and energy meter we can consider for the every 3 revolution in second, that we have to consider. So this is about the tabular column. So we'll while connecting the experiment, we note out those readings in this tabular column and do the calculations. Thank you. To this energy engineering lab. Today we are going to discuss about two-stroke single cylinder petrol engine test rig. So what is the aim of this experiment is to conduct the performance of this engine. Okay, the most of these engines are uses for this performance. Here there are different engines we are seeing in this lab. So here we are conducting from this experiment brake power, specific fuel consumption, and brake thermal efficiency, and other parameters we are going to find out. Okay, let us discuss about the what are the elements on this equipment or test rig. We will discuss right now. So here there are main switch on is there, and fuse will be there, and everything will be digitalized here. And here you can see the RPM. You can find out this speed of the shaft here, and this is the ammeter reading, and this is the voltmeter reading. So earlier case what we are doing for the manual load we are putting, but here in this test rig we are taking, instead of manual mechanical load, we are taking as electrical load in terms of electrical ammeter current and voltage, and this is the engine off and on switch. So we can operate like this. Okay, and these are the temperature of the air. When you put it on like this, you will get the air temperature through the sensor. So we can find out these values, and this exhaust temperature when you are taking out the exhaust gas from this engine, that we can find out through this sensor, and we can note it down through the digital reading. Okay, so and these are the fuel tank where the petrol is already, you know that the petrol is combined with the air, so that will call it as a charge. That charge is going to be taken into this engine to run this engine, and what is the procedure basic of this experiment is, we have to count down the 10 cc of fuel, how much it takes for 10 cc of the fuel to fill in that flask. So that we have to take down through the help of a stopwatch. That is one thing. And here, welcome to this here. These are all pipe arrangement you can see here. So one is connected to the orifice, and here the fuel will be connected to the engine here. And there are different thermocouple wires are connected at the various points to know the temperatures of inlet and outlet. So this is the generator. Okay, so this is shaft we can observe here. So here the sensor is provided through, it's not necessary to find out through the tachometer. So digitally we can find out this the speed of the shaft. Okay, so this the design of the supplier of this equipment, they are given some prescribed standards. Okay, so here they are given test rig comprises following these three important. One is for the engine coupled to the DC generator and measurement and control panel, and sensors, and along with the RPM and temperature is given. And the engine specifications are, one is this is for the Bajaj Chetak engine we are taken here, and the capacity of this is 2.2 kilowatts, and the compression ratio is 7.4:1. Okay. And ignition is the spark ignition, as it is the petrol engine, it is a spark ignition, and cylinder diameter means the bore is 57. And this is the tabular column, that is observation table. Here in this table we can find out manometer difference, that is H1 and H2 in terms of manometer height, and speed is in RPM, and load we can consider the electrical load, that is the voltage and ammeter reading, and fuel consumption time for 10 cc of fuel collected in the flask, and here the temperature for the air inlet and exhaust temperature. Okay, let us start with the engine, and by kicking this engine. So here we are starting the engine by kicking this nut, and here the speed here, and this is the main on. So if you want to use this, we have to on this, so we will get the reading right. Okay, these are all the manometer reading, and this is the fuel tank. Through this fuel, the fuel is going to pass. So if you take it on, the fuel is going to be entering into this engine. And these are the RPM and ammeter reading and voltmeter reading. So here each knob is having 250 watts. Suppose if you on this is the 250 watts of volt power is going to be supplied. Okay, like that we have to on. And these are the temperature indicator for this exhaust and inlet. So this inlet is, as we are connecting at the room temperature, that is 20 degrees centigrade. Okay, and if you want to find out the exact temperature, it is 81. So it means that the combustion is taking place and exhaust is released. Okay, so this is the way of reading. First, what you have to do for every 10 cc of fuel, you have to count down the time. Okay, so that time will be considered for the fuel consumption. And this is the speed. Speed you can control. Speed for the engine, you can. This is the speed. Okay, here the speed control will be there. So this is how to proceed. Once every few seconds, you have to switch off this control panel, and the engine will be off. Okay, this is the way of conducting the experiment. Thanks for watching.